As part of the LIFT grant, we at Chemistry and School of Computing created and implemented 5 mobile apps available for free on the Apple App Store and the Google Play Store. Each of these apps were created to solve their own problem. However, for the purpose of this video, we will focus on the more visually appealing one, which is 3D SimOp, which helps with spatial visualization. So with the study of infrared spectra, the bands on the infrared spectra are due to vibrations in the molecule. And these vibrations in the molecule is dependent on the symmetry or lack of symmetry in the molecule. Hence, for the interpretation of the bands in the IR spectra, molecular symmetry present has to be established. So traditionally what happens in the classroom is a 3D drawing is drawn on a 2D whiteboard. And students have to do mental manipulations, for example, rotate. And we call these mental manipulations symmetry operations. And to do that is to work out the symmetry elements. For example, the molecule drawn can be rotated by 360 divided by 4, which is 90 degrees, around a vertical axis. And we call that a C4 rotation axis. So some problems we identified is that certain students have difficulty in doing these mental manipulations, for example, rotation, so leading to a difficulty in identifying the symmetry elements, followed then by an inability to then assign the vibrations in the IR spectra. So what we did is we created a mobile app, 3D SimOp, which students can use in the app-assisted interactive tutorials. Okay, so 3D SimOp, let me share with you the app, is an educational app designed to visualize symmetry elements and operations on molecules of various point groups. So we go into the app. The 3D molecule is searchable via 4 ways: name and formula, 2D structure, point group, and image recognition. So we choose one of the molecules, then the symmetry elements, rotation axis C, reflection plane sigma, inversion point I, and improper rotation S can be selectively displayed on the scalable 3D molecule. On touch, the symmetry operation, for example, C4, which is a 90-degree rotation, is performed, and the user can pause and resume the movement at any time. If we click this button, the corresponding 2D image with the symmetry element can also be shown. Tapping the point group symbol will also display the character table. If we go back to the home page, a quiz mode is available, for which each time has 7 symmetry element questions, followed by 3 point group questions for the student's self-assessment. So in one of the app-assisted interactive tutorials, rather than doing a mental manipulation, which some students find hard, the app allows the molecule to be operated on, which means to rotate, reflect, invert the molecule within the app. So according to the symmetry element, this can be done, aiding their dynamic spatial visualization. Following this, the students then draw out the molecule with the symmetry element, reinforcing this dynamic spatial visualization. So to evaluate the educational value of the app, the post-test versus pre-test percentage increase for those who use the app more frequently was greater than those who use the app rarely. So overall, we think that the apps like 3D SimOp can complement the suite of resources that are available to our students.